So let's say we're asked to draw this particular function. F of x equals x squared plus 2x minus 8. So first of all, you can say that it's going to cut the y-axis when x is equal to 0. So I'll just write that down. Cuts the y-axis when x equals 0. So that means that when the x is equal to 0, it cuts the y-axis. So we put 0 in for the x here. So that's going to be 0 squared, 2 times 0, and you'll just get a value of minus 8. So y must equal minus 8. So the first point we have on our graph of this function is going to be the point 0 minus 8. Now we can say that it's going to cuts the x-axis when the value of y equals 0. So that is whenever x squared plus 2x minus 8 equals 0. So we can factorise this here. So we factorise it as it's a quadratic equation. So it's going to be x and x. So what values we can use? 4 and 2. So we're going to have x squared. So it'll be plus 4x minus 2x equals 0. And you can see that when we multiply that out, we're going to have x squared plus 4x minus 2x is plus 2x, and minus 2 times the 4 is minus 8. So we're going to have the value x is going to equal 2 and x is going to equal minus 4. So those are the roots. So it means we've got another 2 points. We've got the point 2, 0 and minus 4, 0. So I'll just underline some of these points here. So we've got a point here, these 2 points here. I've also got this point up here. Now we're interested also in the turning point. So we get a turning point when f derivative of x is equal to 0. So we can differentiate this. So we'll have f derivative of x is equal to, well, that's going to be 2x plus 2. So we get a turning point when f derivative of x equals 0. So that's going to be 2x plus 2 is equal to 0, or x is equal to, well, that's minus, take the 2 down, so that's minus 1. So we get a turning point when x is equal to minus 1. So what's the y value? Well, your y value is just going to be your minus 1 back into the original equation, so it's going to be minus 1 squared plus 2 times minus 1 minus 8. So that's going to equal a value of 1 minus 2 minus 8. So that's going to be minus 10 plus the 1 is minus 9. So it means the turning point is going to be minus 1, comma, minus 9. Okay, so that's another final point that we're looking for. So we'll draw this graph just down here, just a quick sketch of it. So we can see that the turning point is minus 1, minus 9, so it's somewhere down here. And it's going to cut the axis, the y-axis, at a point along 0 down 8. So it's going to be somewhere along, if I continue this down, it's going to be somewhere round about here. And it's also going to cross the x-axis at points 2, 0 and minus 4, 0. So you're going to have, say, 2, 0, and you're going to have minus 4, 0. So you're going to have a curve that kind of comes down like this. This is the turning point here, and it's going to come back up here. And these points here are going to be the 2, 0, and it's going to have a -4, 0. You're going to have -1, -9 for the turning point. And finally, you're going to have this point here, which is the point that crosses the x at the y-axis, which is going to be 0, -8. So that's a rough sketch of the function. So let's go and we'll put it into the graphical calculator and see if we get these actual points, and the function does look like this. So let's put our curve in and see whether we've got the points correct. So it's going to be x squared plus 2x minus 8. So this is our curve here, so let's check our points out. It cuts the x-axis at -4, 0 and 2, 0. It cuts the y-axis at 0, -8, and the turning point is -1, -9. So that's our curve, and it is correct. So I suggest you try and draw out a few curves in the graphical calculator, and then go and work out individual points on the curve using the process that I've just gone through in this example. So thanks for listening. I'll get you on the next video. Goodbye.